Let us discuss a new concept, that is interior point. Okay, let us see the definition of interior point. See, if XD be a matrix space and A be any subset of X, if there is some point X, okay, let us see what is definition of interior points. If I ask you in general, if you don't know the definition, just you have to guess and tell me, is X is an interior point of A? Obviously, our common sense says yes, X lies inside A, so that's why we say it is interior point. If I draw X here, can I say it is an interior point? Obviously, your answer will be no. X lies outside A, so that's why it is not an interior point. But if I draw X on boundary of A, and if I ask the same question, is X interior point of A, then some maybe you will get confused. Some of you will think that yes, X is an interior point since it is lying on boundary, but maybe some of you will think that it is not an interior point since it is on boundary, it does not lie inside a set. Okay, so let us avoid this confusion. So what is the definition of interior point? If the point lies inside A, that means mathematically we can say if there exists R, definition says if there exists R, there exists a radius, positive radius, such that open ball with center X and radius R entirely lies inside A. There exists a radius R. I am not saying for every R. Huh? In open set we say for in there exists. So here also there exists some radius R such that open ball with center X and radius R entirely lies inside A. If okay, let me remove all these X. If you consider X here, yes, it is possible to draw ball around it which entirely lies inside A. So therefore X is an interior point. Okay, I will draw here Y. Do you think Y is an interior point? Yes, Y is also an interior point. So in this case also, it is possible to draw ball around Y which entirely lies inside set A. So Y is also an interior point. If I draw or if I plot one point Z which is very close to boundary, and if I ask you the question, is Z is an interior point? In that case also we will say it is an interior point of A, because in this case also we can take a very small radius such that open ball with center Z and that radius R entirely lies inside A. So Z is also an interior point. If I go outside and if I ask this W is an interior point, no, since basic condition is that point should be in that set, then we can call it as interior point of A. W lies outside a set, so that's why there are no chances that it is an interior point of A. But now if I take a point P which is on boundary, then what do you think? It is an interior point? Then it is not an interior point because it is on boundary. If you take any ball, any small ball around P, then definitely some part of ball will go outside set A. So therefore in that case, if any point lies on a boundary, we will say it is not an interior point. I hope all of you understood the definition. So see, after that we will discuss examples, but one important notation is a set of all interior points of A is denoted by A interior, getting set of all interior points. That means if we have some original set, so we will find interior points of that set, and set of such interior points is denoted by A interior. You can make a screenshot of it. After that we will discuss few examples. See, let us discuss few examples. See, RD, where D is a usual metric we have, and we have to discuss or we have to find set of interior points of a given set. The first set is A open interval 0 1. So you know that when we consider open interval, that means it does not contain this boundary points. 0 and 1 are not included. So see, if in a given set, if you select any point X, then definitely we can find a ball around X which entirely lies inside a set. So therefore we can declare it is a interior point. We cannot discuss 0 and 1 since 0 and 1, these points are not mentioned, not given, not included in a given set. So that's why no need to worry. But if you select any point of that interval, you will find it is an interior point. So a interior is the whole set open interval 0, 1. Let us go for the second condition, second example, that is close interval 2, 3. Getting 2, 3. See, in this case, the set contains its boundary points 2 as well as 3. Okay. If I take any point x between 2 and 3, then definitely we can find open ball around x, which entirely lies inside a interval 2, 3. So therefore, every point in between 2 and 3 is an interior point. But what do you think about 2 and what do you think about 3? 2 is an interior point? No, 2 is not an interior point, because if I draw any small ball around 2, the ball, some part of ball is going outside the set. So therefore 2 is not an interior point. Similarly, we can say 3 is also not an interior point. Since any ball around 3, some part of ball goes outside the set. So therefore the set of interior points is open interval 2, 3. You are getting? So boundary points we have removed and the remaining points we have taken there. Next set is set of natural numbers. So natural numbers, you know, 1, 2, 3, 4. Okay. So we have to find interior points. So let us discuss 2. What do you think? 2 is an interior point? If you draw ball around 2, then that ball contains infinitely many rational numbers, irrational numbers, many points. Okay, there are no only natural numbers. Getting? Actually, ball should contain natural numbers only, but it contains many numbers other than natural numbers. So therefore 2 is not an interior point. Similarly, 3 is also not an interior point, since any ball around 3 contains many points other than natural numbers. So therefore there is no point is an interior point. So it's 5, nothing, empty set. Next, q, rational numbers. So q, suppose I take any rational number p upon q, and if I draw ball around that point, so you know that density theorem, there is irrational number between any two rational numbers and there is rational number between any two irrational numbers. So if I draw ball around rational numbers, so there are many irrational numbers. Getting now? So that means ball is going outside a set. So there is no any interior point of q also. Close, see, we have a next interval which is open at 5 but close at 7. What do you think? X is a interior point. Yes, any ball around x lies inside a set. 5 is not given in a set, so we cannot discuss 5 is an interior point or not. But 7 is in a set. What do you think? 7 is an interior point? No, since if you draw ball around 7, some part of ball going outside a set. So therefore 7 is also not an interior point. So points, all points between 5 and 7, that means excluding boundary. So that is a set of interior points. So these examples you can note down, and after that we will stop. Thank you. Bye bye.